All right, let's dive right into this explainer. If you've been tracking the incredible evolution of electric vehicles, you already know that building the cars is literally only half the battle. The real frontier? The grid itself. Today, we're taking a structured deep dive into the realities of powering our electrified future. We are going to unpack the brand new Q1 2026 report to the California Air Resources Board from Electrify America, and we'll also weave in a pretty fascinating new off-grid update from Alpine Energy. We've got a lot of incredible data, and definitely some surprising roadblocks to cover, so let's get started.
Okay, let's dive into this roadmap for today. We'll start with 1, the EV charging landscape. Move into 2, delivering power and speed. 3, powering priority communities. 4, heavy fleets and innovations. And finally, 5, roadblocks to expansion.
Section 1, the EV charging landscape, a macro view. When you consider Electrify America's current footprint, the sheer geographic density is honestly wild. We're talking thousands of fast-charging stations spread out across 47 states and the District of Columbia. It's this massive, highly interconnected web built along heavily traveled highway corridors and regional routes. But while that national footprint is totally impressive, we want to focus specifically on the tip of the spear for EV adoption, and that's California. This huge national scale perfectly sets the stage for the specific regional data we're about to explore. So, zeroing in on California for Q1 2026, the numbers are pretty substantial. The network currently boasts over 1,300 chargers across more than 270 sites in the state alone. But it's not just about building new stations. It's really about constant improvement. In just the first quarter of 2026, 18 existing stations were upgraded with 85 brand new next-generation chargers. It's a continuous cycle of investment that ensures the infrastructure doesn't just age in place, but actually evolves to meet the growing demand.
Moving right along to Section 2, delivering power and speed, the hardware behind the charge.
If you spend any time in the EV space, you hear a ton of marketing buzzwords. Let's demystify that jargon so we know exactly what these speed categories actually mean in terms of raw kilowatt power. As defined in the report, hyperfast isn't just a fun catchphrase. It specifically designates chargers capable of delivering up to 350 kilowatts of power. Ultrafast, on the other hand, refers to chargers delivering up to 150 kilowatts. And importantly, depending on how many cars are plugged in at once, the power cabinets can balance that load dynamically.
Now, what's really interesting here is the state-of-the-art tech inside the casing. This is the Generation 4 or Gen 4 direct current fast charger. To push 350 kilowatts of power into a vehicle without everything overheating, these units actually utilize state-of-the-art liquid-cooled cables that are certified to UL standards. It's an absolutely brilliant piece of engineering that Electrify America was the first to deploy in the US, making sure that high-power charging stays safe, efficient, and reliable for everyday drivers.
But let's be real. Great hardware is completely useless if it doesn't connect to your car. To handle this, the network is keeping interoperability wide open. They primarily use the non-proprietary CCS connector, which serves the current market majority, while still supporting legacy CHAdeMO vehicles. Crucially, though, they are actively adapting to the future by piloting the new J34 system, or NAS connector, at 2 locations right now. Plus, they're prioritizing seamless payments through standard credit card readers and ISO 15118 plug-in charge technology. Basically, you just plug the car in, and the network automatically handles the payment. No fumbling around with apps required.
Which brings us to Section 3, powering priority communities, equity and infrastructure.
The data surrounding new deployments is incredibly impactful. Think about this. In the first quarter of 2026, there were 27 new direct current fast charging sites commissioned in California. An impressive 70% of those newly commissioned sites were strategically located in what the state identifies as low-income and disadvantaged communities. This shows a very deliberate mapping and real estate strategy to ensure equitable access to high-speed charging where it's needed most.
And this really illustrates the broader trend across the entire network. If we look at the corporate strive to achieve targets set for these low-income and disadvantaged community investments, the goal was 35%. However, the actual commissioned network deployment across California currently sits at 55%. That means more than half of the public fast charging stations they operate in the state are serving rural, low-income, or disadvantaged populations. They are significantly over-delivering on their initial equity commitments.
All right, Section 4, heavy fleets and innovations, beyond the passenger car.
Before we look at massive port microgrids, consider the complete opposite extreme, total off-grid isolation. Alpine Energy just unveiled a first-of-its-kind vehicle-to-vehicle, or V2V, EV charger. This is built precisely for environments where the traditional power grid simply can't reach. By allowing one massive battery to charge another directly out in the field, innovation is stepping in to solve these critical off-grid charging gaps. And honestly, this concept of localized, independent power acts as a perfect bridge to understand how larger networks are handling their own grid strain.
And that brings us to these incredible setups, Battery Energy Storage Systems, or BESS. Electrify America operates more than 100 stations coupled with these massive battery arrays in California alone. Over 50 of them operate together as a virtual power plant. What this means in practice is they draw power from the grid during off-peak hours when energy is cheap and carbon intensity is super low, store it in these cabinets, and then use it to charge cars during peak hours. It reduces reliance on costly peaking power plants and makes the whole local grid way more resilient.
And this localized power is absolutely vital when you scale up to heavy-duty logistics. Take 4Gen Logistics as an example. They're deploying 44 chargers for 60 massive electric heavy-duty trucks down in Long Beach and Rialto. Then you have NFI Industries out in Ontario utilizing 38 dispensers backed by 4 megawatts of battery storage just for their drayage trucks. And over in the public sector, the Causeway Connection provides electric transit bus service from Davis to Sacramento, operating entirely within those priority communities we talked about earlier. This is heavy, real-world infrastructure keeping supply chains and people moving.
Now for the reality check. Section 5. Roadblocks to expansion.
27%. I really want that number to sink in. According to the Q1 2026 data, it costs on average 27% more to design and construct a station in California compared to building a station with the exact same number of chargers in another state. Because of this premium, California literally gets fewer stations per dollar invested. And the source makes it completely clear, this isn't primarily because of the hardware costs. It is driven almost entirely by permitting and utility energization delays.
So, the crucial point is, where exactly is the bottleneck? Let's walk through the actual timeline. First, the permitting process alone averages 62 business days, which, by the way, is 18% longer than the national average. Then, utility design takes an agonizing 38 weeks. Next comes the actual physical construction of the station, but look at step 4. After the station is completely built and ready to go, the utilities take an average of 32 weeks just to complete their end of the construction and actually turn the power on. That is over half a year of fully built chargers sitting completely idle, just waiting for a switch to be flipped.
These logistical hurdles also bleed into existing network maintenance. For example, there was a recent dip in Level 2 charging efficiency at multi-unit dwellings and workplaces. The network delivered 0.78 gigawatt-hours in Q1 2026, which is a 28% decrease from the previous year. Impartially reporting from the source material, this temporary drop wasn't due to a lack of demand, but rather a vendor transition happening behind the scenes. It really highlights how reliant this complex ecosystem is on seamless third-party partnerships.
Which brings us to our final and maybe most important thought. We've seen Generation 4 liquid-cooled chargers, massive virtual power plants, totally off-grid V2V innovations, and heavy-duty logistics hubs. The technology is clearly here, and it's highly advanced. But, as we've also seen, it faces a 32-week wait just to get energized. So the provocative question we have to ask ourselves, and the one I'm going to leave you to ponder today, is this: can our brilliant technological deployment ever truly outpace the bureaucratic red tape that is holding back the grid? Thank you so much for joining me to explore the fascinating data behind our electrified future. Keep learning, and I'll catch you next time.